Hey, 8th grade. Today we're going to be continuing our unit on chemistry. Our lesson for today is about element families, which is really important because this is going to set the stage for element bonding later on this week. Our essential question for today says, what are 3 element families and how are they different? So let's talk about what an element family is. Elements can be divided into groups or families. You guys may remember from a couple months ago that a group is a vertical column on the periodic table, and a period is left and right. It's a row on the periodic table. So we're going to be talking about groups when we talk about element families. Elements of the same family have similar chemical properties because they have the same number of electrons in their outer energy levels. That is huge. That's the main thing they have in common. They have the same number of electrons in their outer energy levels. If you look at the picture on the left, they're all color-coded for you, all the different families. We're going to focus on 3 of them in particular today. We will talk about the noble gases, which are in purple over here on the right side of the periodic table. We're going to talk about halogens, which are right next to them in light purple. And then way on the other side, on the left-hand side of the periodic table, we have our alkali metals in that reddish-orangish color. So let's first talk about noble gases. So elements in group 18 have 8 electrons in their outer energy level. These are the noble gases. So if you look at our Bohr model of neon, you'll notice that it is all filled up, right? We know that energy level 1 can have up to 2 electrons, which it has, and energy level 2 can have up to 8, which it also have. It's all filled up. You can't fit any other electrons in there. So this element is stable. That's great. That's the goal. We want our elements to be stable, to be all filled up with electrons. So because noble gases are stable, they are not very reactive. Scientists originally thought that they were completely non-reactive, but we know now that that's not true. Because they're so stable, they're used in everyday life frequently. So they're used in light bulbs for the filaments, and then they're also used in neon signs. If you look on the bottom left, you can see what each of those noble gases would look like in real life. That's 5 of the noble gases. They actually do shine that color in real life, which is kind of cool. All right, let's talk about our halogens. Halogens are elements in group 17, and they only need 1 more electron to be stable. We have fluorine off to the left side of your screen. Fluorine has a total of 9 electrons, which means they have a vacancy. Look, right over here. They could still fit 1 more electron into their outermost energy level. So fluorine is not stable, but it is so close. It wants to be stable. It wants to get an electron from another element. So the easier it is for a halogen to gain an electron, the more reactive it is. So fluorine is up at the top of their family, which means fluorine is very reactive, way more reactive than elements beneath it in its same family. Okay, last but not least, let's talk about alkali metals. These are elements in group 1. Remember, that's on the far left side of the periodic table. They have just 1 little electron in their outermost energy level. Because of this, they are highly reactive. They will be able to share that electron with pretty much any element that wants it. You can see potassium on the left side of your screen. In potassium's outermost energy level, it has just 1 electron. That means this element is very reactive. The easier it is for an alkali metal to lose an electron, the more reactive it is. So it's opposite of a halogen. All right, that's it for today. Go to Google Classroom, answer your question of the day.